See, next one is column subjected to axial load and moment. You can see the two diagrams, left and right side. Left shows the column subjected to axial load and moment in one axis, where the right side diagram which shows column subjected to axial load and moment in two axes. See, the first one is development of interaction diagrams. So from above to these diagrams, the intersection diagram of the failure envelope of RC cross sectional contain the different combinations of mu plus and pu. The result in the failure of the cross section as shown in the above diagram. Thus, the interaction diagram a graphical representation of all possible combinations of axial load and bending moments that causes failure for a gives a cross section. In order to develop the interaction diagram, we need to have a dimensions of the sections, the longitudinal reinforcement FCK and FY values. The intersection diagram can be developed by using compatibility of strain and equilibrium forces and moments. When the axial compressive load applied to a short column, it will be subjected to a uniform strain or the shortening as is shown in the figure, next figure. So, when the axial load and the moment be the applied at the same time, the resulting strain diagram will be the combinations of linear diagram will be itself is a linear. As a result of a linearly, we can assume contain certain numerical values of strain is one of the part of the column determines the strain at the other location of straight line. So, you can see here 5.3 which shows the strain depending upon the pu and the moment. First one is axial load, second one is moment, and third one is axial load and moment. See, as the axial load applied to a column in the change, the moment the column can resist will be changed. This section always show how the interaction curve of normal axial load and the moment value can be developed for the particular columns. Assume that concrete on the compressive edge of the column will fail at the strain 0.003. A strain can be assumed at the far edge of the column, and the value of pu and mu can be computed by statics. Holding the compressive strain 0.003 on the far edge, we can then assume the series of different strains on the other edges of calculated pu and mu. Each eventually a sufficient number of values will be obtained to plot an interaction curve, such as in one of the shown in below figure. You can see interaction diagram for RC cross sections, pure bending, moments, balance point, interaction diagrams, pure compressions. This is the pure bending versus the axial load. This is a diagram. Say pure bending, the point represent that of a beam in bending. Note to the presence of a small axial forces will be generally increase the moment of capacity of the beam. Balance point, this is the point where the concrete reaches its ultimate strain at the same time tension reinforcement yield. For combination that pu and mu that fails below the balance point, the failure mode is the ductility with the reinforcement yielding before the concrete fails in compression. Otherwise, the failure mode is the brittle, the concrete crushes without yielding of the tension and reinforcement. Unfortunately, the failure mode in the columns cannot be controlled by the reinforcement quantities. It can be beams. Pure axial compression, at this point the columns is subjected to axial force only with mu equals to 0. The capacity of the sections is equal to pu. Note that the tension reinforcement yielding compression force in this case. So, next is design of a column subjected to combined axial load and uniaxial moment and the biaxial moment by using SP16 chart. The design of members subjected to a combined axial loaded and uniaxial bending will be involve length calculations in a trial and error method. In this order to overcome these difficulties, interaction diagram may be used. These have been prepared and published by BIS in SP16 design at reinforcement concrete to IS 456. By using these design adds, we can easily design the column subjected to combined axial and uniaxial biaxial moment. Interaction curves are rectangular and circular columns with symmetrical arrangements of steel. For these grades, steel for various d1 divided by d values are be given in chart 27 to 62. These are the charts. The design SP16 be based on the non-dimensional parameters pu divided by fck into b into d and mu divided by fck into bd square, where pu is equal to axial ultimate load, mu equal to limiting moment, fc is equal to characteristic strength of the concrete, b equals to width of the column, d equals to overall depth of the columns in the direction of the movement. So, procedure of using SP16 interaction diagrams, design aids: find the steel of members subjected to combined axial load and uniaxial bending, gives the size of columns, grade of concrete, grade of steel, otherwise assume suitably, factor of load and factored moment you have to assume, arrange in a reinforcement on 2 sides or 4 sides, that is very important, moment due to the minimum eccentricity to be lesser than the actual moment, substitute the axis bending based on the given moment xx or yy, suitable diameter of longitudinal bars, suitable nominal covers, compare the following, that is d dash divided by d capital from effective cover d dash, non-dimensional parameters pu divided by fck into bd and mu divided by fck into bd square, referring the appropriate charts from SP16 and p divided by fck, and here and hence the percentage of reinforcement p. Steel from AS equals to P into B into D divided by 100. Provide proper number of arrangement from the steel. Design suitable lateral reinforcement. Sketch the reinforcement detail. Procedure for using SP16 interaction diagram for design aids. Find out the steel bars and members of subjected to combined axial load and biaxial bending. Give PU, MUX, MU, Y grade of concrete and steel. Check the eccentricity EX equals to MUX divided by PU and EY equals to MUY divided by PU are not less than corresponding to the minimum eccentricity as per the IS 456-2000. Assume a trial sections for the columns square, rectangular or circular. Compare MUX and MUY corresponding to the given PU using appropriate curves SP16 design aids. Ensure that MUX1 and MUY1 are significantly greater than the MUX and MUY. Calculate PUZ and hence the alpha n. Check the adequacy of the sections using the interaction equations.